So this is a question that I have taken. Is it visual, right? Here we have to calculate resistance offered by spot. So how will we calculate this resistance? In automobile industry, electrical resistance welding is used for spot welding steel panels, each of 1.5 mm thickness, 1.5 mm thickness, and the weld has an area of the weld is given 2 mm into 2 mm. The current used is given 1000 ampere, and the amount of heat required to melt this spot balloon is 36 joule, while electrical resistivity of the steel is 8 micro ohm centimeter. So what will be the resistance? How will we calculate? Anyone? Did you get the question? Hello? And apart from this question, we have to calculate the time required to perform the weld. What will be the time? T weld. So how will we calculate? Any idea? This is a live mentoring session and people are not even responding. So here we know resistance R equal to rho L by A, and here length we have to see this is 1.5 mm into 1.5 mm, two different steel. Therefore rho thermal electrical resistivity which is given 8 micro ohm. So let us change it in ohm centimeter, and this L means this is 1.5 mm each of 1.5 mm. So it is two plate. So 1.5 into 2, this is mm. So we will convert it into centimeter plus 1 divided by area. Area is given weld area 2 mm into 2 mm. 2 into 20 into 20, not 20. 0. 0.2 into 0.2. We can add 2 into 2 into 10 to the power 2. So this is 2 into 2, 4 mm square minus 2. So if we solve, we'll get 6 into 10 to the power minus 5 ohm. This is the right option. And how will we calculate time? Any one knows any formula? Second, I square RT. Yes, we know Q equal to heat V into I into T, and we also know voltage V equal to I into R. So from here we can get I square RT. R is given, I is given ampere. It is 1000 ampere into R. We have already calculated 6 into 10 to the power minus 5, and T we have to calculate, it is in second, and Q is given 36 joule. 36. So from here we can find T value. 36 by square into 6 into 10 to the power minus 5. So we'll get 60T equal to 36. T will be 36 by 60, which will be nearly 0.6 second. 10, 0.6 second. First one. Is it okay? Yes, it will be 0.6 second. Prakash, is there any issue? Okay. So I am going to next question. I have solved this question earlier. Can you try? How will we solve? Anyone? Here, an operator in a steel plant wants to reduce phosphorus level in steel by treating it with an appropriate slag. The equilibrium phosphorus distribution ratio between slag and liquid steel, weight percent of phosphorus in slag, weight percent of phosphorus in slag divided by weight percent of phosphorus in steel. It is given 100. For a chosen slag composition, assume before the treatment the steel contains 0.28%, means the steel has a 0.28% phosphorus. And if the operator treats 1000 kg of liquid steel, if we take 1000 kg liquid steel with 100 kg of slag, we have to find out the resulting phosphorus content in the liquid steel. How will we solve? Like suppose it is given 0.28% steel. So can you tell me amount of phosphorus in steel? What will be the amount of phosphorus in kg? This is 0.28% phosphorus in steel, and we are taking 1000 kg of steel. So yes, 2 kg, and this is 100 kg of slag. So if we treat this together, steel and slag, then some amount of phosphorus will go into slag. So suppose x amount it goes into slag. So x amount of phosphorus in slag. So total amount, remaining amount of phosphorus in steel will be 2 minus x. Is it okay? Kg, 2 minus x kg. And we know this equilibrium phosphorus distribution ratio. So from here we can calculate x value. So can you tell me what will be the x value from here? Simply weight percent of what is the weight percent of phosphorus in slag now? We know x kg. This is phosphorus. It is in 100. X by 100 into the amount total is 100 into 100 divided by 2 minus x. Total amount of steel is 1000 kg into 100, and it is equal to 100. So can you find out what is the x value? Are you guys solving, right? What is X value? The amount it is in kg. This is a phosphorus content which goes in slag. We are assumed x kg of slag of phosphorus in slag. So what will be the x value? 20 by 11. So it will come nearly 1.81 kg. So this is 1.81 kg phosphorus after treating 1000 kg of steel with 100 kg of slag. So what in equilibrium, what is the amount of remaining phosphorus content in steel? 2 minus x, 1 minus 0.8181. So it will be how much? 0.1818 kg. So here we have to find the resulting phosphorus content in liquid steel will be. It is asking percentage. So what will be the weight percent? Can you tell me what will be the weight percent? This is in kg. So 0.1818. Total amount of steel is 1000 kg. So this is per kg. So for 100, this will be the amount in weight percent or percentage you can say. To cancel down, it will be 0.01818 weight percent. So option D is the right. Is it okay? So now question 56 you guys are solving. You know idea how to solve, right? In second question, 50 kg of slag early operator use a 50 kg of slag and then again 50 kg of slag. So at the end you have to find out phosphorus content in steel. It is also in weight percent. So how will we get? What is the procedure? I already solved this one. Prakash, is it okay? You can ask. You guys unmute yourself. Hello. Do you want me to solve this one also? Hello. Okay, okay, Prakash. Kamesh. You can unmute yourself. You can speak here. Kamesh, there is no issue. Like even there will be some audio, then we can manage. Okay. Instead, the operator treats the 1000 kg of liquid steel with 50 kg of slag. So again we will solve it by same procedure. This is 1000 kg. Suppose early it was 0.28% phosphorus. So 2 kg of phosphorus in steel, and we treat it by 50 kg. So suppose 2 minus y kg of phosphorus goes in slag. So can you tell me y amount? What is the amount of y? So y means simply will write y by 50. We are using 50 kg total slag into 100. We are converting it in weight percent. 2 minus y by 1000 into 100, and this is equal to this equilibrium phosphorus distribution ratio, which is 100. So now can you tell me what is the amount of y? What would be the y value? 1.66, yeah, 6 kg. So this is phosphorus content in slag in kg. So the remaining uh, phosphorus in steel will be 2 minus y. That means how much? 0.334 kg. This is remaining phosphorus content in kg after treating with 50 kg of slag. It is saying then the processed slag is removed and another 50 kg of fresh slag is added. So we will apply the same procedure. Now we know in steel the phosphorus content is 0.334 kg. This is 1000 kg slag steel, and slag again we are treating it with 50 kg of slag. So here suppose um, a amount a kg of slag, a kg of phosphorus goes in slag from this one. So the remaining will be 0.334 minus a kg phosphorus in steel. So again we will apply this distribution ratio and we will find out a value. So what will be the a value? Again in this case second, if the processed slag is removed and another 50 kg of slag is added. Are you getting? Either in issue you can ask. So simply you write this a by 50 into 100. This is in weight percent, so that's why I am multiplying by 100. 0.334 minus a by this is 1000 kg of steel. into 100. Can you now tell me what is the value of A from me? Yes, 0.2778787. This is kg. So this much kg of phosphorus goes again in slag after treating the slag second time. So it is asking the resulting phosphorus content in steel. So what will be the phosphorus content? How will we calculate? This much, right? 0.334 minus 0.278 kg. So how much we will get in steel? This will be 0.0556 kg. This is in steel. So it is asking weight percent support 0.0556 by 1000 into 100. So it should be 0.00556%. So option C is the right. Is there any issue? You can ask. Is it okay? Prakash and Sanjit, you can ask me if there is any doubt. You guys are also here, right? Prakash and Sanjit. So we are moving to next question. This is simple question. Can you solve? Interplanar spacing like for FCC cubic crystal cubic system. What will be the interplanar spacing? If we suppose it is D, then what will be the formula we know? A by h square plus k square plus l square. And this is actually for this plane. So HKL value we know 220, and the interplanar spacing, the atomic radius is given. So what will be the A value? This is FCC. So what is the relation A and R? Atomic radius, and this is this length A, lattice parameter 0.128. Okay. So from here you can calculate D equal to, you are getting right. A value if you put, and you put 2 4 plus 4 8. 0.3620. and from here d value will be equal to 0.3620 by root 8, which will be 0.128 nanometer. And same we know Bragg's formula, lambda equal to 2d sine theta. Here it is given for 1 n lambda it is, so we already have assumed it is 1, so we know 2 into d is given, we already calculated 0.128 into sine theta, and lambda value is given, the wavelength 0.154 nanometer. So from here we can calculate sine theta value. 0.6015. So theta value sine inverse this one, which will be nearly 36.98. Okay, and this is also a simple question. This is two question means what will be the answer? Like first one is easy one, but second one, first you solve this one first one. Like what will be the maximum possible reduction in a single pass? 12. So we know delta H, H1 minus H2, me square R. So it is given 0.1 square into radius is given, so simply 2 mm. So what will be there here? You read this second question and how will you solve it? Here the thickness of plate is reduced from 30 to 60 to 30 mm by multi-pass rolling, and roll radius is given, friction coefficient of friction is given, and we have to here assume equal draft in each pass. So how minimum number of passes required to reduce the thickness from 60 to 30 mm? What will be the answer? Okay, how do you solve? Sanjeet and Prakash, how will you solve? Sanjeet, are you here? Are you present or not? Okay, Kamesh, can you tell how did you get 4? Okay. Here the thickness of plate is reduced from 60 to 30 mm. Roll radius is given 350 mm, and mu coefficient of friction 0.15. And we have, if we assume equal draft, then we have to calculate minimum number of passes. So we already know for a single pass delta H max maximum, suppose it is first pass, it is equal to mu square into r. So already coefficient of friction is given 350. So from here we will get 7.875 mm, and here it is so total reduction is, suppose delta H, it is 30 mm, 60 minus 30, so we will get 30 mm. So total reduction will be equal to, suppose n number pass, and this is assuming equal draft, so delta H max first, so this is 30 equal to n into 7.875, so n value will be equal to 30 divided by 7.875. So here we will get 3.8. So number of passes minimum required, it will be like 4. 8, okay. Sanjit and Prakash. Can you tell me what will be the Miller indices of the direction common to the planes 111 and 110 in a cubic system? How will we solve? Then tell approach you. For planar means suppose yes, Miller indices is HK. So it, if it lies in this plane, then normal of this plane and this plane, it will make 90 degrees. So H into 1 plus K into 1 plus L into 1 equal to 0. And similarly for second node, if it lies in this plane also, we can write H into 1 K into 1 plus L into 0 equal to 0. So H plus K equal to 0, we can write H equal to minus K. This. So H equal to minus K, and we know this equation also. So this is second equation. So we will put second value in first one. So minus K plus L equal to 0. So we will get L equal to 0. So we have already assumed HKL Miller indices. H value we know minus K we can write. K value suppose K and L 0. So if we take a common K, we can write minus 1 1 0. This is, we can say bar 1 1 0, bar 1 1 0. So option C the right. Yes, dot 1 0. Is it okay? Even if you may get the option like 1 bar 1 0, it will also be correct, because from here we can write also k equal to minus h, and if you put, you may get this one. So both is correct. The engineering stress curve for a ceramic material is, what will be the, this is one marks question. Linear, it forget, yeah, linear should be. This is a good question, you can try. Prakash Rao, previous slide means this one. Ceramic means for ceramic, it is brittle type ceramic. That's why we get a straight line, linear. And previous slide means you were saying about this one. Okay. You have any question, you can ask. Is it okay now, Prakash? CI systems. Yes, yes. You try this one. Here, a metallic rod with 2 mm into 2 mm square cross section is being tested in tension and has the following mechanical property. Mechanical properties are given. We have to calculate the rod. The rod is loaded to 1000 Newton. The magnitude of transverse strain. I tried this question and I solved wrong. That's why I'm saying, can you try? You try your set first. This is simple question. You can, but you may make some minor mistake, silly mistake. And this is a good question. How to find resilience? Are you guys trying or not? Okay. Everything is given. Just you calculate what will be the transfer system. Poison ratio is also given. This is square cross section, not diameter. Don't take it down. So it is loaded like, so what will be the stress? Simply we calculate P by A. This is 1000 Newton. This is 2 into 2 square cross section, not diameter. So what I did, pi by 4 d square, I did 2 into 2 into meters. We are converting it in meter square. So we'll get 2 to 4, 250 into 10 to the power plus 6 megapascal. This is pascal, 250 megapascal. And elastic modulus is, young modulus is gigapascal. So what will be the transfer strength? It will be sigma by 250 is equal and 100 gigapascal. This is megapascal, so gigapascal we converted it in megapascal. So it will be 2.5 into 10 to the power 10 to the power 3 minus 3, and it is asking percent 0.25%. What is the modulus of resilience? How will we calculate? Anyone? Sigma square divided by 2e. So how will you calculate? Can you try? There is a small catch here. You try it first. After that, I will tell you. I was also facing issues in this question. You were right. Like you told, no, resilience it will be like sigma square by 2. You can catch from this equation also. What is E? What is sigma? From here you can find out. Hmm. Yeah. Poison is right. This is suppose cross section. So you know gamma equal to, this is sigma x by sigma y. Longitudinal. This is length. This is diametrical. No, I think it is transfer strain. It will be this one, because if we are loading, this is tension. So there will be a strain in this direction. Are you getting? Sanjay? Hmm. Yes. It is asking strains. Yes. So you take a Poisson ratio also. Poisson ratio is given where it is 0.3. Poisson ratio means it is sigma x by sigma y, right? If I remember correctly. So what value you are getting for transfers? Okay. So this one is the right one. What will be the modulus of resilience? You just told resilience. It will be sigma square by 2e. This is yield stress. Are you getting? Not pure this stress values and not conventional stress. So can you tell me what will be the modulus of resilience? There was earlier one question related to eutectic temperature. During solidification, if this temperature is given, this temperature is given, we can find out undercooling this one, this much amount from this triangle, total triangle and this one. So from here, if you plot stress and strain diagram, you can find out. For example, this is your yield stress, and here you, if you see, yield stress is 500 megapascal, and here it is the rod is loaded up to 250 megapascal. So it is loaded up to 250 megapascal, and it is 500 megapascal, 7 megapascal. And here you have just calculated how much this one 0. What is the strain then? It is percentage. So strain will be 7.5 into 10 to the power minus 3. Is it okay? It is 7.5 or 0.75. Okay. So now can you find out resilience? Oh, 1.5. So here, suppose this is strain. Suppose the strain is x. Here this amount we know. So from this triangle, we can find out x value. What is the x value? Means uh, strain at yielding. At yield. This is symmetry, right triangle. Yes, 250. Let us know 250 divided by 0.75 into 10 to the power minus 3, and it will be 500 divided by x minus 0. So from here you can calculate x value, and resilience we already know, you have told that 1 by 2 sigma square. We will take this value 100 megapascal. Sorry, yield strength, this one 500 megapascal. 500 into, you can take this x value simply, there is no need to change it in yield stress. 1 by 2 into yield stress into strain, and this is your yield stress, and this is strain up to yield stress. Is it okay? You can apply this one also. So you we are getting this one, right? We are getting 0.57 or what? How much? What is the value? Sanjeev? Okay, okay. then we will get the same, because we know already E equal to sigma by epsilon. So even if you put here 1 by 2 into sigma into epsilon means sigma by E, same 1 by 2 into sigma square by E. So you will we are getting 1.25. I don't have calculator, so please check. 25 megapascal. Okay. Is there any issue? Per meter cube. Is there any issue, you can ask. You just take it, because this is yield stress. Modulus of resilience. Modulus of resilience is actually the area. This, suppose this is here fracture. This area is modulus of resilience, and total area. This total area is what? Can you tell me what is the total area? This area plus this area till fracture. It is called toughness. If you want to calculate, then total area we have to calculate. Is it okay? Okay. This is also a simple question. Two metals which provide cathodic protection of steel. In electrode uh, potential series, you will find that this zinc and magnesium, they are placed higher, so they act as a cathodic protection. So Q and S, this option is right. Can you try this one? 1 mole of monoatomic ideal gas is reversibly and isothermally expanded to 1000 Kelvin to twice its original value. What will be the work done by the gas? Here work done, we know W equal to, for reversible and isothermal system, we know N RT ln. It is expanded from V1 to V2, V1 to V2, suppose V2 by V1. So this is for 1 mole. R, this is gas constant 8.314. Temperature is given, and it is saying twice its original value. So 2B by B. So it will be ln2 simply. ln2. So this much joule we will get. Is it okay? Is there any issue, you can ask? Let us solve last question. The atomic radius of iridium in nanometer. Here density is given and atomic weight is given. How will we solve? We know this is FCC means 4 atoms, and density is given 22400 into 10 to the power 3 gram per meter cube, and mass of 4 atom will be 4 into this much. This atomic mass is given 192 per atom. It is for per atom 192.2, and we know Avogadro number. This is gram per gram. Avogadro number will be 06.023 into 10 to the power 23. This is number per gram. So AQ. This is volume. So volume, what will be the volume of this iridium? From here you will get, from here you can get volume, and for FCC we already know relation between A and atomic radius are A root 2 equal to 4R. So R will be equal to A root 2 by 4. So from here you can calculate atomic radius. Is it okay? So do you guys have any question you can ask? Is there any issue?